Paris, 1896. The weather had taken a turn for the worse, and one downcast Henri Becquerel had tossed his experiments aside. Returning days later, he eyed the faint silhouette of a crystal in his desk drawer. Little did Henri know, that shadow was the key to the future of human advancement.
Nuclear physics was born that day, allowing us to look at the smallest things in our world,
so that we can explain those most expansive.
To best understand the universe, we first need to start small.
Very small. What Becquerel discovered on that dreary evening was that his uranium salt crystal experiment did not need the radiance of the sun to emit energy,
But rather emitted it themselves. This inspired a deeper dive by a Polish emigre living in abject poverty, Maria Skłodowska.
now known as double Nobel Prize winner Marie Curie.
Foregoing food to afford books, she heavily analysed pitchblende for emitters of radiation. Her research revealed two radioactive elements, polonium and radium, through her husband's piezoelectric quartz electrometer. These new, perhaps deadly elements were so fascinating to the pair, they carried samples around in their pockets.
These curiosities developed into questions at the forefront of Italian physics.
What happens when the atom itself is disturbed?
In 1934, in a cramped laboratory in Rome, a group of young physicists led by Enrico Fermi,
The Pope of Physics,
sought to answer this.
the Via Panisperna boys combed through the periodic table, bombarding each element with neutrons, discovering that slower-moving neutrons were far more effective at penetrating nuclei than faster ones. After exposing uranium to radiation,
Results were astounding.
new radioactive products were formed.
Products which didn't neatly fit into the periodic table.
The only explanation was that they had created a new and heavier element, for which Fermi was awarded the Nobel Prize in Physics.
However, true comprehension would come a few years later in Berlin.
Chemists Otto Hahn and Fritz Strassmann ran a similar experiment, but it was Lisa Meitner, exiled to Sweden under Nazi persecution, who, in secret contact with Hahn, had the vital realization that these nuclei were splitting apart, releasing enormous amounts of energy in line with Einstein's famous E=mc² equation. She named this process nuclear fission. Despite her essential theoretical contribution, Meitner was unfortunately excluded from the 1944 Nobel Prize, which was awarded only to Hahn.
Fleeing persecution from fascist Italy, Fermi touched down in America in 1938.
As the country was knee-deep in the top-secret Manhattan Project, he was thus quickly approached to head the creation of a nuclear reactor,
A piece of engineering so powerful it could not only revolutionize the war,
but the very essence of energy production worldwide.
The project was set to take place in the depths of Chicago University, unbeknownst to even its own president. The reactor, Chicago Part 1, was a 20 feet tall matrix of uranium graphite, studded with control rods. In 1941, it carried out the first controlled nuclear fission.
While Chicago Part 1 is now disassembled, its life forms the basis of nuclear energy in our modern era.
Powering 15% of our lives, a figure that continues to rise every day as we tap deeper into the potential of the atom.
From a destroyer in France to the future of renewable energy, nuclear physics has proven to be pivotal to humanity. An interest in physics isn't halted by discrimination or poverty, not even a spot of rain. Those who are able to understand how the universe around us works don't have some superhuman ability.
They simply have the unbridled, persevering desire to take a closer look into if,
Why,
And how everything works.
and how we might tame it to our advantage.